Okay class, let's start with video number 4 for chapter number 2. Okay, so this is lesson 2.2, General Hooke'S Law. Now in General Hooke'S Law in my lecture before is actually chapter number 5. And bakit ito tinawag na General Hooke'S Law? Now, because we will now consider deformation in the x, y, and z direction. Now, we have the General Hooke'S Law as described in lecture number 2. We have sigma is equal to strain times E. Okay. Kung lalagyan natin ng x, lalagyan din natin ito ng x. Lalagyan din natin ito ng x. Okay, now, because ito. Because our material is homogeneous, for example, steel, wherein our E in the direction of x will be equal to in the direction of y, direction of z, and gagawin natin E na lang, especially for homogeneous material like steel. So, kumbaga ito na lang na dalawa na ito ang magkakaroon ng subscript. That is in the x direction. And actually, we are using that in the General Hooke'S Law, tinatawag natin as the uniaxial loading. Uniaxial loading. Ngayon, may kakaroon tayo ng sigma y equals to strain y times E din. Kung ang uniaxial din pa rin siya. Uniaxial pa rin siya but in the y direction. So, ibig sabihin, it depends on, it will be the direction. But we only have one load. One load. Okay. Ngayon, yan yung uniaxial loading. Sa General Hooke'S Law natin, General Hooke'S Law, magkakaroon tayo general na ng dalawa, wherein yung isa is uniaxial and the triaxial na tinatawag. Triaxial, which is divided into the biaxial, and the general case. The general case, which is triaxial. Actually, general case. Ngayon, may makikita kayo mga formula dyan na mas mahirap pa memorize, although pag sanay ka, madali lang din. Pero I would rather give this as para mas madali siya. Doon tayo pumunta sa general formula. General formula. Okay. So, kapag kasanay kayo dito sa general formula na ito, lahat yun makukuha mo na. So, ang gagawin lang natin dito, ganito. Lagay tayo dito ng strain x, strain y, and strain z. Then, gawin natin yung equation na yan. Tapos dito, pag x naman, then y, then z dito. So, dito, lalagyan natin ng sigma x over e, sigma y over e, then sigma z over e. So, lahat lagyan natin. Sigma x over e, sigma y over e, then sigma z over e. And last, we have sigma x ulit, sigma x over e, sigma y over e, and sigma z over e. Ngayon ito, lagyan mo ito ng Poisson's ratio. By the way, before we start, tinatawag natin na yan is V is the Poisson's ratio. Poisson's ratio. Okay, may definition yan. Then ito, lalagyan ito ng V or U, depende sa definition, that is the Poisson's ratio. Pag x yan, xx, dito po positive, dito magiging negative na dalawa. Then dito, since y, ito na magiging positive. Then ito negative dito, then negative din dito. Wait lang. Sigma x. Sorry. Mali pala. Wait Mali yung lagay ko ng v. Dito walang v. Dito ang lalagay tayo ng v sa ano. Pag ito x, ito lalagay na ng v. Then dito lalagay ng v. Sa pag y, dito naman ang wala. So dito naman ang meron. Saka dito. Then dito say, dito naman ang wala. Dito naman ang meron. Ito meron. So ito magiging negative. Ito negative. Tapos positive. Then ito magiging negative, positive, negative. Then positive, negative, and negative. So ibig sabihin, we will have this equation for strain in x. Strain in x. So in the triaxial case, ibig sabihin we have strain in x will be equal to strain in x over e, then minus v strain in y over e, then minus v sigma c over e. Ngayon yung pwede nating ilabas. So we have 1 over e, then this will be sigma x, then minus, okay, ito pwede nating ilabas yung v, then magiging ano mo yung lalabas if this, kung gawin natin ito ng plus para maging negative, okay, negative, yes, negative ito v, then we have sigma y, then plus na sigma c. Okay, para madali ipag-memorize na. Okay, so we have sigma y, strain y will be equal to negative sigma x over e plus, okay, may v ito, plus sigma y over e, then minus v, then sigma c over e. Ngayon lalabas, makuha mo na ito, 1 over e, then lalabas ito, this will be sigma y, then minus b, then sigma x plus sigma z. Okay, so magiging ganyan yung ano natin, yung formulation para mas madali. Okay, so we have strain in C will be equal to negative V strain in X over E plus this negative, sorry, it will be negative. So it will be negative V sigma y over E, then plus sigma c over E. So pag nilabas natin yung E again, 1 over E, then this becomes sigma z minus b times sigma x plus sigma y. Ayan na. This is actually ang tawag natin dito is the general Hooke's law. That is the general Hooke's law equation na tinatawag. Hooke's law. Okay. Ngayon, pwede natin, kung marunong kayo sa matrix na form, kung makita nyo yung diagonal dito, walang V, no? Actually, yan yung diagonal of the, so, actually, yung equation natin is equal to stress is equal to strain times E. So, kung kukunin natin yung strain will be equal to sigma over E. Ayan na yan, nilagyan na ng X. But in as general, if we have now strain in X, strain in Y, then strain in Z, and gagawin natin as vector, this will be equal to 1 over E times this matrix. We have 1, 1, 1, negative V, negative V, negative V dito, negative V, then negative V, and negative V dito. Then dito you will have now the stress in X, stress in Y, and stress in Z. So ganyan yung mag-equation yan. Now, so for example, you have now yung kukunin mo yung uniaxial case. Uniaxial case in the X direction, and the X direction ng load, no? So, ibig sabihin yan, you have sigma X, but your sigma Z is equal to 0, as well as sigma Y is also equal to 0. Wala kang load dun sa, ibig sabihin yan, may PX ka, wala kang PY, wala kang PC, kung load yung tinutukoy natin. So, equate mo lang ito sa 0, magiging uniaxial na yan. Ngayon, kung biaxial, ibig sabihin, halimbawa, ang load mo, biaxial nasa X, and Y ang load mo, ibig sabihin, meron kang PX, meron kang PY, no? Pero wala kang PC. So, this simply mean that meron kang sigma X, meron kang sigma Y, pero wala kang sigma C. So, sigma C is equal to 0. Equate mo ulit ito sa 0. Ito naman, equate mo ito 0. Then, may value ito. Then, ito may value din. Lalabas, biaxial yan. Biaxial case, na? Biaxial case. Ngayon, pag in-expand mo ito, yan dyan, lalabas itong equation na yan dyan. And that make this topic more easier than using the formula. But anyway, let us look at our discussion. So sabi dito, ganito yan. Kapag meron kang sample bar, yung axis ng load ang tinawag na X, then yung vertical dito ang Y, then we have say here. So kapag siyempre yung material, so for example, ganyan yan. Okay, ito tayo. So, baba tayo. So, pag halimbawa ganyan yan. Let's assume that it is kahit na solid, kapag nag-apply tayo ng load P, mag-expand yan, pero in the lateral, mag-contract. Kaya mangyayari niyan, liliit siya. Magkakaroon siya ng hahaba siya, pero liliit siya dito. Liliit siya din dito, magiging contraction dito, din dito, extension, yung strain, yung direction. This will be strain Y, strain Z, and this will be strain X in that direction, corresponding sigma X, corresponding sigma Y, and corresponding sigma Z. Okay, ganun yung ibig sabihin ng dito sa diagram na ito. So, ito ngayon yung uniaxial case. Ito yung uniaxial case. So, we have yung strain natin sa Y and Z direction magiging negative V this strain in X. Now, what is Poisson's ratio? Poisson's ratio actually is defined as the ano yan? Okay. Yung kasi, yung V, yung V is equal to negative strain in Y over strain in X. There is a negative strain in Z over strain in X. Kaya pag kinumpute mo yung strain in Y, will simply be equal to the strain in Z, and that will be equal to negative V strain in X. But what is strain in X? Diba ang strain in X is equal to sigma over E. Kaya nagkaroon tayo ng equation kanina sa derivation dito sa bandang taas, no? Sa bandang taas nakikita itong mga expressions na ito. Itong mga expressions na ito. Ayan ay may mga value ng v, yung mga value ng v. Kasi kapag in the direction of the load, wala tayo yung direct ano yun, yung simple Hooke's Law equation na ito, walang v dito, now so that is for uniaxial loading. Okay, that is for the uniaxial loading, and we have also this equation here. So we also have this equation here, ito. Okay. For multi-axial loading, we have the biaxial load. So meaning you only have load in the x and y. You only have load in x and y. Ang sigma z natin is 0. Pero kahit na since we are considering the biaxial load, or general Hooke's Law, kahit nang stress natin sa Z0, meron pa rin yan ng strain sa Z. Ang strain sa Z is not equal to 0. Hindi, meron pa rin yan. Then, for triaxial load, ito na yan, makikita nyo dito sa mga expression na yan, ito na yan. Ito yung sinulat ko kanina. Ito. Biaxial nga lang ito. Biaxial ito. Na formula na yan. Ngayon, kapag triaxial, ito yon yung triaxial na sinulat ko kanina. Yung triaxial. Ito yun. Ngayon, marami pa kayong i-memorize dyan. Mas madali kung dito na lang kayo. Tapos yung naka matrix form. Okay. So ito, ang tinutukoy natin dito, General Hooke's Law, considering normal stress and normal strain. Kaya lang, yung stress natin in the 3 direction, okay, x, y, and z. Ngayon, ano naman yung shear loading? Yung shear loading natin, ito yung sinasabi ko kanina, na kapag halimbawa meron kang element, kasi usually ang tinutukoy lang natin dito is yung thin element lang thin element, hindi na siya yung thick element na may x. So halimbawa meron tayong xy plane lang, so meron tayong shear dito, ang shear na yan doon, papunta rin doon, then ito papunta rito, then ito papunta rito. So these are pure shears, actually wala tayong normal stress. So that is for shear tau din ito, then dito tau, then dito tau din. Then mangyayari niyan, ang magiging magdi-distort yan, magiging iba na yung position niya, no? So this is normal, dati 90 degrees na 90 degrees. Then siyempre ito hindi na magiging 90. Ang tawag dito sa rotation na to is the designated as parang ganun, that is the shearing strain yan, shearing strain. Since shearing strain is in the form of rotation, the unit will be in radians. Radians ang unit niyan. Hindi millimeters per millimeters. Okay. So, although in the computation, magkakaroon pa rin tayo ng normal strain dyan. And, by the way, kanina, meron tayo ng dito. Yung relation ng saan yan dito? Yung relation ng E sa V. Relation ng E sa V. Saan yan? Kasi meron dito. Wala pa dito. So, anyway, hindi nakalagay dito sa module. Na kumbaga, dito pagdating sa shear stress, pag titingnan nyo, we have stress is equal to strain or modulus of elasticity times strain. Then kapag shearing, tau is equal to G times, this is yung shearing strain na tinatawag ka na. So, stress ito, strain, stress, strain. Kumbaga ito parang Hooke's Law, pero ito in terms of normal stress, ito in terms of shearing strain, itong G. Ano ngayon yung G? Ang tawag sa G is modulus of rigidity. Modulus of rigidity. Of rigidity. Okay. So, that is modulus of rigidity. And yung hinahanap ko kanina pala na relation between modulus of rigidity and E and yung Poisson's ratio, ito yan. Huwag niyo kalimutan ito. That is G is equal to E over 2 times 1 plus E. Okay. Huwag niyong kalimutan yan. Now, before we solve problem, let me show to you first my chapter 5. Now, yung chapter 5 ko in my old notes. Chapter 6. Okay. So, dito, sa General Hooke's Law, Poisson's ratio and General Hooke's Law, papakita ko lang sa inyo yung yung this lecture number 6. Yung white itong open ko. Ito mo isa. Ayan. Okay. So, kung makikita nyo dito, for lecture number 6, Poisson's ratio, General Hooke's Law. So, I have here first, the definition of the Poisson's ratio V. Ito yan. As the lateral strain to the axial strain, pero may negative. And I have here the definition of isotropic and anisotropic material. Okay. Now, this is for the uniaxial case wherein ito yung example ko. Ito yung illustration wherein I only have the load in this direction. So, ang tendency is mag-elongate yung bar pero liliit siya. Kumbaga ito yung original niya. No? Then, for the general axial case, ayan, yung illustration ko. Then, I have this. If you have load in the x direction, therefore your sigma y and sigma c is equal to 0. And we have this equation for strain na may V. Galing lang naman sa yan, sa Hooke's Law, no? At saka yung definition ng Poisson's ratio. Then, for the biaxial case, ito yung formula. Okay. Then, note that sigma c is equal to 0. So, may load kasi ako sa x and y. Then, for the general Hooke's Law, ito. So, pinakita ko sa inyo kung paano ito i-derive. Na formula ito. Kung paano ko ito ginawa. Yung diagonal, walang V. Then, yung lahat ng may V, negative. Yeah, negative. So, kapag ka x ito, x yun, walang V. Kapag ka y, dito naman yung walang V. Then kapag ka ito z, andito naman yung walang V. Pero ito yung diagonal, positive. Then it will arrive to this formula, which I have shown you kanina. Then ito yung sinasabi kong General Hooke's Law, wherein naka-matrix form. Naka-matrix form. Kumbaga, mas madali mag-compute dito sa mga ganitong marunong kayo ng vectors and matrices sa calculator. Okay. So, may dagdag ako dito, dilatation hindi nakasama. Then, yung modulus. Okay, in a way, may importante din sa itong dilatation. But I will just add this. No? I-add ko na lang sa special lecture, no? Titingnan ko yung yung mga lectures, then dadagdagan ko na lang with respect to this lecture, no? Okay, so balik tayo sa module natin. Okay, so sa module natin we have sample 2.2.1, the 50 mm diameter rubber rod is placed in the hole with rigid lubricated walls. There is no clearance between the rod and the sides of the hole. Determine the change in length of the rod when the 8 kN load is applied. U is equal to 40 megapascal and V is equal to 0.45 for rubber. B. So, rubber yung natin, yung 50 mm rod rubber. Ngayon, ang E is 40 megapascal, hindi gigapascal na megapascal. Sabi dito, ang load natin is in this direction ng 8 and andito yung direction ng load. Then, ito yung ginawa nating x-axis. Then, dito yung y. Then, yung direction dito will be yung sa z direction. No? Z direction. Ngayon, sabi dito, yung sigma x of course will be equal to P over A. So, just substitute the value and makukuha nyo is in Pascal. So, usually, mas maganda nito kung naka-megapascal lang. Anyway, this is from our module in our what's this references. Anyway, just convert nyo lang yung value na yan. Okay. Ngayon, anong mangyayari ng case natin? Meron tayo ng load, dito lang tayo mayroong load. So, ibig sabihin, wala tayong sigma y and sigma z. Wala tayong sigma z. So, this is a uniaxial case. But, ang mangyayari niyan, in the lateral, since walang clearance, magkakaroon tayo ng load. Magkakaroon tayong load. This is yung P. Sorry. Wala pala tayong clearance. Since kinukompress natin yan, kung may clearance, sana, uniaxial. Ngayon, since walang clearance, magiging triaxial ito. Kasi may PTI dito. So, supposedly, yung rubber natin, i-exit, but yung lateral, i-expand. So, ano mangyayari sa expansion? Since hindi siya maka-expand, restrained siya dito. So, ang mangyayari sa kanya, magkakaroon tayo ng stress dito due to load lateral, paikot actually. Kaya magiging triaxial case tayo. Kaya makikita nyo itong formulas ito, mayroong sigma y, sigma c, and sigma x. And our lateral load, the sigma y and sigma c will be equal to this value of P. But since this is in compression, by the way, I forgot to mention kanina that in the dun sa formula natin, kahit dun sa matrix, yung sigma natin dapat magiging positive if in tension and negative if in compression. Kailangan may sign convention tayo dyan. Susunod tayo ng sign convention dyan. That's why using that formula, we're able to solve for the value of P. And since given naman yung mga value na yan, nakuha natin yung value ng P is equal to 33.333 times 10 to the 6 Pascal. And we were able to solve for this strain using this formula. Then that the strain in the x direction is negative 0.02686. That will be in millimeters. Anong given natin dito? Pascal, yes. That will be in millimeters. This should be, since this is strain, this is unitless, but this should be millimeters per millimeters. And you are now going to use the formula deflection. Di ba meron tayong formula na strain is equal to deformation over L. Gagamitin mo lang yung formula na yan. Then, if this is x, then you'll also have stress and strain in x direction, deformation in x. And you're just going to multiply it by L, makukuha mo na yung contraction of the material. Ngayon, ang nakalaan dito, for comparison, kung halimbawa, rubber band lang yan, babalik tayo sa chapter 2.1. Kung meron tayong load dito and we have that area, P, wala tayong constraining value dito. This is free to expand. And therefore, our formula for P is just magiging uniaxial case na siya. Magiging uniaxial case, and therefore, we can use this formula now, P over A, or gamitin natin yung uniaxial case, then you will get this. The negative, the deformation or the contraction is equal to negative 30.6. Then, as a comparison, di ba, malaki yung contraction niya kaysa dito sa negative 8.06 kung restrain siya. Siyempre, ano siya kumbaga, na-hold siya Hindi siya makapag-expand, kaya hindi siya basta-basta makapag-contract. Yan ang ibig sabihin itong problem na ito. Now, I suppose this problem will be difficult for you. So, let's try to solve this using my style. Using my style. Okay. So, ang gagawin ko dito, erase ko muna. So, mag-erase muna tayo. Then, I will extract the problem. Okay. So, kayo na bahala mag-solve Kayo na bahala mag-solve. I will just show to you the solution kung paano siya i-solve. So, mag-snipping tayo. Kunin natin yung problem. Okay. Okay, at least yung problem. Control copy. Then, punta tayo sa OneNote. Okay. Sorry, OneNote na. Okay. Control paste. Okay, dito siya. Okay, natin siya. Okay. So ngayon, ang mangyayari, uniaxial case, So ang gagawin nyo dito, para mas madali yung solution, ganito na lang. Kasi kung minsan, nahihirapan yung mga estudyante pag mga ganyan problem, especially sa books. So ngayon, let's take the given. Our diameter is equal to 50 millimeters. And there is no clearance. Then the change in length of the rod when the 8 kilonewton determine the change in length. So our P and the direction of X is equal to 8 kilonewton. And E is equal to 40 megapascal. And opposite ratio V is equal to 0.45. Okay. So ngayon, ang natin diameter is 5. Therefore, we can compute for sigma x. Our sigma x will be equal to px over the area. Yung area natin will be, by the way, this will be 8,000. Converted ko na times pi over 4 times 50 mm. Diameter ng 50 squared. So, I will use my calculator. So 8,000 then madilim ay so our answer is 4.074. 4.074. So 4.074 megapascal. Okay, that is our sigma x. Okay, now our length is 300 and our diameter is 50. So ito na yan. So in megapascal, megapascal. Although we know that it's in compression, so this should be negative when substituted, not negative. Then next, ang tinatanong is determine the change in length of the rod. Ngayon, ang nangyayari dito, wala tayong wala tayong load sa X. Supposedly, dapat yung sigma C and equal to sigma Y supposedly equal to 0 if no constraining factor. Ngayon, hindi. This is not valid kasi sabi dito wala daw clearance walang clearance. No clearance. Because walang clearance, so magkakaroon dito ng effect. So this will be subject to full compression lahat. Then it is assumed that here that sigma Y will be equal to sigma Z and this will be equal to negative P. So meaning pressure yan. Ginawa na lang pressure. So P. Ngayon, from the General Hooke's Law, equation, kung titingnan natin, we have strain in X, strain in Y, then strain in. Okay, actually, ganito yung equation na ginagamit ko. This will be equal to 1 over E. Then we have 1, 1, and 1. This is negative V, this is negative V. Negative V, and negative V, and negative V, negative V. Then maglalagay tayo dito ng stress on X, stress on Y, and stress on Z. Ngayon ito lalabas, this will be negative 4.074. Then this will be equal to negative P. Then this is equal to negative P. Okay. Ngayon, since wala tayong clearance dito, ibig sabihin yung material natin hindi magkakaroon ng yung delta, yung delta X will also equal the delta Y, I should say, will also be equal to 0. And delta Z will also be equal to 0. Ngayon, kung 0 yung dalawa na yan, this simply mean that if deformation in Y is equal to 0, this follows also that the strain in Y is also equal to 0. If the deformation in the Z direction is also equal to 0, then therefore the strain in Z is also equal to 0. So ibig sabihin, we are going to equate this to 0, and we are going to equate this also to 0. You will see here that this equation for this two will be the same, no? So if that will be the same and we have given a V value, we can solve for P here by using kahit na alin sa dalawa. So in our equation we can write 0 will be equal, gamitin natin itong sa gitna, will be equal to 1 over E, okay, times marunong ba kayo mag-multiply ng nasa gitna tayo, ito negative B will be multiplied by itong negative B will be multiplied doon sa negative 4.074. Okay, ito yun ito alam ko malilito pa kayo dito. So ito ang kinukuha yung strain in Y. Ngayon ito kukunin nyo, tapos itong negative B i-multiply natin doon, then plus ito i-multiply dito, so magkakaroon tayong minus P. Ito na, minus P na lang. Then dito ito pa, then ito at saka dito magiging plus V times P. Okay. So ngayon, makikita nyo, pag bumalik ako dito, ito yung expression na yan. Ito yan, makukuha nyo ito. Ito yan. So, Makikita nyo doon kung paano kinuha yung P. Ito yan yung expression nito dito. Ito yan. So yan yung expansion. Kapag in-expand mo yan, ito yan actually. Ito yun. Ito yun. Kung makikita nyo. So makukuha natin yung value ng P. Okay. So, if we are going to substitute the value, we have 0 will be equal to 1 over E. Now our E is, what is the value of E? 40? Yes, 40. So this 40. Then we have negative V. What is V? Is 0.45. So that is negative. So negative times negative magiging positive na yan. 0.45 times 4.074. Okay. Then minus, yung kasi 1 times P. So minus P plus 0.45 P. Okay. So, kumbaga, itong 40, i-multiply natin doon, magiging 0 na. No? Wala na. Sa lalabas, we have 0.45. Transfer na lang natin dito. We have P minus 0.45 of P will be equal to 0.45 times 4.074. And this will be equal to, so 0.45 lang naman yan. I will solve P. That will be 0.45 times 4.074, then divided by 1 minus 1 minus, sorry, ulitin mo. Ano yan? 0.45 times 4.074, then divided by 1 minus 145 equals, so you'll get 3.33. So we'll get 3.33 megapascal na ito. Megapascal ang unit natin because we have used here 40. What is that 40? What is the unit? Yes, megapascal. Okay. Now here, ang pinakita ko dito is pascal. Pascal. Anyway, they are just the same. So 3.333 times 10 to the 6 pascal. And that is equal to this 3.53 megapascal. Okay. Ngayon, ang tinatanong dito sa question is the deformation, determine the change in length of the rod. Kapag mga ganitong problem, nandito tayo sa General Hooke'S Law, ang tatandaan nyo, kapag ang tinatanong nyo yung mga change in length, triaxial case kagad kayong problem natin, triaxial case kagad. Ngayon, change in length, huwag niyong isipin muna ito kaagad. Ito muna ang isipin nyo, yung strain muna. Yung strain. Kasi gagamitin natin yung formula na ito. So, yung strain in X ang kailangan natin muna. Strain in X. Ngayon, dito makikita natin dito. Kaya natin mag-solve dito sa formula nito. So, you will see here that our strain in X, okay, so dito sa baba. Strain in X, kapag in-expand natin, will be equal to 1 over E. Then we have, paano yan? Okay. So ito naman, ito, i-multiply natin dyan. So we have 1 times negative 4.074. Okay. Then, minus, ito, negative BP. So magiging plus na. So plus 0.45 yung 0.45 times yung P is 3.33. Okay, ito yan. ito at saka ito, plus ito at saka ito. So, negative i-multiply na lang natin ito ng 2. Ano? Multiply na natin ng 2. Then, substitute for E equal to 40. Then, we will get the value equal to what? Okay. Negative ang makukuha natin kasi yung that is compression. So, divide na natin 40. So, 0.45 times 2 times 3.33 minus minus 4.074 equals divided by 40. That will be equal to negative 0.269. So negative, I will just second tama ito na negative 0.0269 millimeters per millimeters. Okay. Now, let us check our answer sa module. So, ang strain na makukuha natin is 0.02686. Okay. So, tama tayo. Okay. Now, 2.0269. Then, after that, saka ka na mag-solve ng using the formula strain in X will be equal to times yung length sa X, no? So this negative 0.0269 times ilan yung length sa X natin in the X direction, that is 300 mm. So 300 mm. And this is equal to negative, so 0.0269 answers times 300. And that is equal to, 0.0269 times 300 plus. So, that is 8.07. So, negative 8.07 millimeters. Okay? Okay, so let's check if that's correct. Okay, so that is 8.06, no? 8.06 or 8.07 lang dito. Nakakalang 8, negative 8.07 in a way rounding up. So, kung makikita nyo, mas madali dito kaysa yung dito sa module, no? Okay, I hope this will help you. So, that ends our video for this